It's all about, you know, how you can apply some of the techniques that we've seen used in the dating industry, which you maybe don't know, but it's a big industry, right? There's conferences with thousands of people just about the dating industry, you know, it's a big industry, and they apply some really interesting technologies, like, for example, Neo4j, and we'll talk about that a little bit more. So Neo, it's one of the graph databases that's been around for a very long time. It was founded actually early 2000 by a couple of Swedish Vikings that had a particular problem that they needed to solve, and by now it's quite a mature offering for dealing with graph data. There's quite a few customers, and of course open source users that deploy Neo4j. It's one of those things that, you know, people are predicting that it's going to be the next big thing, right? So graphs, they've been around for a very long time, and there's a lot of interest brewing in it. Just to be clear, it's not new at all, right? It's one of those technologies that's been around for a very long time. I don't know if people around here remember mainframe databases, you know, things like navigational or network databases that used to power the world. You know, they were all based on the graph data model, but that's coming back, really. Graph databases are all about, you know, leveraging the data in relationships, in connections, right? When you think about it, relational databases are very anti-relational, right? They're very difficult in dealing with connectedness in the data, right? And graph databases want to solve that problem because there's a lot of value in those relationships. There's a lot of value to be had from understanding how things are connected to each other, right? So new digital processes, all of these different things are happening right now because we try to leverage those relationships. And that's what we see in the dating industry a lot. Like I said, you know, relational databases aren't very good at dealing with relationships because relationships require join operations, right? And join operations across multiple tables, it's okay when it's about 1 or 2 tables, but it gets really, really complicated when either the data set size grows or the number of entities grows, right? If you're doing a join over 1 or 2 tables, that's okay. 5 tables, ooh. 10 tables, ouch. 20 tables, it just doesn't work anymore, right? So, especially at scale, right? So dealing with relationships is difficult in a relational paradigm, right? So we're trying to complement that, and there's been this whole new wave of wonderful new technologies in the NoSQL space that are absolutely great at dealing with scale. You know, if I look at some of my colleagues downstairs that, you know, are promoting the React open source database or the MongoDB open source database, you know, I was chatting to them this morning. You know, it's fantastic technology. You know, it's really great technology, but it really doesn't deal with relationships. It deals with volume. It deals with, you know, simplicity. You know, those types of things, right? And that's really where the graph databases come in. I always think about, you know, the first advantage of working with a graph is a modeling advantage. It's about, you know, modeling reality as it is, right? About drawing networks. Hello. There's a door at the back as well, but, you know, don't worry. You can model reality as a network, basically because reality is networked, right? And you can reimagine that very, very easily. One of the nicest things that I've seen in the graph database space is that you can basically draw the graph, right? So many software projects start with a drawing on a piece of paper, on a whiteboard, on a wall, right? You draw a model. That's how you start the conversation with your business users. That's how you start, you know, trying to understand what people really want, right? Well, if you look at it, it really is very similar to how you would persist that in a graph database, right? Oops, right? So that's the power of animations there. it really is extremely similar. You store reality as it is, right? There's no like impedance between the way you see reality and discuss it with your business users, and you store it in your data persistence layer, right? So that's one of the most powerful aspects about it, and there's wonderful implementation details behind that, but I thought I would try to explain that to you guys using a specific example, which is the dating industry, and sort of take you through the steps that people go through when they're looking for a date online. Not that I know from experience. My wife is listening, that's fine. And then we'll take you through it and see how it sort of applies to business domains, right? So that's the idea. What can business learn from dating, right? So in order to do that, I'm just going to go over here and switch microphones. I'm hoping that this will work. Look at that. I feel like a pop star. I can't see my screen anymore now, but that's okay. So what can we learn from dating? This is really based on what we see with users. There's a lot of dating sites that use graph databases, right? And basically what those people are telling us is that when they try to make recommendations for new dates, new links between people, they look at a number of different aspects, right? It's not just one aspect that will determine whether or not a date is likely to succeed, right? It's actually a combination of different things that will lead to a successful date. And actually many of those dating sites, I don't know if you know this or not, but many of those dating sites, they make an effort not to suggest the best date on the first date, right? Because they want you to come back, right? That's how it works. But they look at these different aspects, right? So we call these all different graphs, right? The friends of a friend graph, the passion graph, the location graph, the safety graph, right? You don't want to be dating someone that you cannot trust, and the poser graph. And we'll go into that a little bit. Right, so meet Jeremy. Jeremy is one of the characters that we'll use in this presentation, right? And obviously, Jeremy has some relationships. He has some friends, right? And these days, we can actually load these relationships from social networks, or we can explicitly ask our customers, who are your friends, right? And who are you related to, right? When you include the second level, right, you get a much broader scope, right? You get a much broader scope, friends of friends, right? And your reach within the network sort of starts expanding as well, right? And there's a lot of research that goes into this, but we actually know that, well, first of all, 7 hops and you're connected to anyone, right? The Bacon principle, right? But 3 hops and has an enormous amount of influence on each other. There's a lot of research that there's a lot of similarity until 3 hops away from you. So we actually want to understand that. We want to understand those relationships at least 3 hops away to see, what we can find as information to make better recommendations for dating, right? So we have a bunch of people, how do we know we're friends? Well, we can ask them, we can read from social network informations, or we can look at some kind of implicit linking, right? We can look at properties, we can look at behavior, there's all kinds of stuff that we can derive relationship information from. But as you can tell, it really is a network. It's a friends of a friend of a friends of a friends of a friend network, right? That's what we're dealing with here. And so we're going to try and store and query and interact with that network in our graph database, right? Not because we want to sort of, some statistics on the population, but because we want to make some kind of a recommendation, right? We want to leverage that information in our dating application, right? Like I said earlier, right, this is really important, and there's a lot of research that has been done about this. And if I can recommend a book about this, it's called Connected. I forget the author, but they know that within 3 hops you are so similar. You may not know people directly, but you are so similar, and your influence is actually carrying at least 3 hops away from you, right? So, and this is just some research that's been done here, and this is why, you know, all of the dating sites are absolutely leveraging this kind of technology, because they know, you know, you have a very high likelihood of interacting with people multiple hops away, right? To illustrate that a little bit, you know, if I have these friends of Jeremy, right? Jeremy is friends with Jennifer, with Peter, with Andreas, right? They have friends of friends, right? They have friends of friends of friends, right? But you want to actually apply that and query that interactively, right? So this is an example, and here's where we got, you know, sort of into some specifics, how you can actually query that type of information in a graph database. I don't know if anyone's familiar with the graph query language called Cypher. Right? Cypher is the query language that Neo4j sort of invented to deal with this kind of graph information. And really, it's kind of ASCII art for graph, right? You're trying to sort of draw out the pattern that you're looking for, and then basically tell the database, you know, this is what I want. You declare what you want. It's a declarative language. And then the database should just go out and fetch and try to match the pattern that you're looking for. So in this particular case, you can see very clearly on the slide, you know, what you're doing is you're finding Jeremy, right? So that's the first sort of rounded arcs that you see around a node, right? A vertex in graph terminology, right? That node is connected to another node, which is a friend, right? Through a nose relationship, right? And you can see the square brackets; those are relationships. The arrows, or the, you know, larger than signs, that's the direction of the relationship, right? And that friend knows someone else, right? That someone else we call FOF, which is the friend of a friend, right? And at the end of that query, what we would like to return is the friend of a friend. So if I actually go to Neo4j here, I have a little sample data set that I'm hopefully able to generate here. So this is the latest version of Neo4j. It's actually a beta version, and the only reason I, you know, use a beta version is because then if I fail, I can blame the beta version. It's a milestone release of Neo4j 2.2, and I have a couple of queries here that allow me to, first of all, create the graph, right? So this is the query that creates the graph. It's kind of awkward. All right, so it's running. Oh my God! All right. I thought it was going to fail on the first query, sorry. So now it's created the graph, and now I can go and look for Jeremy's friends of friends, right? So this is the query that you just saw on the slide, right? Match Jeremy, which is a user. His name is Jeremy, he knows a friend, and that friend knows another friend, right? So if I return the friend of a friend, basically it's going to give me a bunch of subgraphs, right, that match that pattern, right? If I want to actually deal with that in a different way. Can you see this actually? Because the resolution is, as always, very, very good. If I actually want to deal that in a different way and return not just the subgraph, but I actually want to just have the list of names, right? I can just say, okay, from the FOF over here, right, extract a property, right, the name property, and give me that list, right? So that's the list of the friends of our friends. Right, so that's what's happening here in that first aspect of, you know, this dating application. I'm looking for the social connections between people, and I'm basically hopping around. Right, I'm grabbing Jeremy, 2 hops down, I find people that are connected. Actually, in Cypher, there's some really cool tricks that you can do to make this even easier. Right, so if I say here, I really shouldn't be doing this, but this. Right, so star dot dot 2, that means a variable length relationship of maximum 2 hops, right? And that will return me the same thing essentially, right? And it's 2 hops away, right? If I make that 3 hops away, I will get even more people, right? So that's the way it sort of goes. You can express the pattern that you're looking for by specifying that in Cypher. So that's, oh, what am I doing? That's the friend of a friend aspect, right? So some of the interesting aspects, for example, are, you know, who do I share friends with? You know, that's another extension of the pattern, right? I'd love to see, you know, who are the people that I share most friends with, because those people are going to be most interesting for me to sort of expand into their networks and find some kind of ordering, right? Some kind of ordering of people that I might be wanting to date. Right, so this is another query where basically what I'm doing here is I am trying to find the friends of a friends, but I'm ordering them by the number of friends that we have in common. Right? Length collect friend is basically that that measure. Right, so it's the length of the path. I can run that query very easily here as well. Right? I run that over here and I get an order. I can basically start getting closer to that recommendation as part of that first aspect of graph-based recommendations, which is the social network, right? So that's already interesting, right? So this can be very important, right? Sometimes you have more than one type of relationship that you want to be analyzing, right? Not just the friends relationship, but also the works for relationship. You know, it's not just the number of hops that can be important. It's also what kind of a relationship do we have. You know, I'm not sure if we want to be recommending, you know, that someone dates their boss, right? That would be a silly kind of recommendation. Even that's awkward, right? The other one, you know, 2 hops away, right? Maybe, but it's complicated, right? Maybe that's interesting, but it's still complicated. For this particular situation where the first hop is a works for relationship, and after that you have friends relationships, you know, it's actually much more interesting to look 3 hops into the network, right? Not just, you know, 2 hops, but also 3 hops. And I showed you earlier how easy it is to do that, right? So you can draw out these patterns. You know, this is like the long notation of it, right? Knows, friend of friend, knows, friend of friend of friend, right? Or you can just say knows star dash dash 3, dot dot 3. Right? That would be the easy way to note that. Right? That's what I was indicating earlier. I'm hoping that's clear, right? So you can leverage that kind of social information. Now we'll start adding some additional perspectives, right? Because that's the real important thing here with these dating applications. They look at more than one aspect. They look at these many different aspects, right? So we'll look at a different user in this particular case, guy called Jonathan, right? A very interesting character apparently, right? And Jonathan obviously has this other aspect that he wants to involve, which is, you know, his passions. You know, what is he passionate about? What are the things that he cares about, right? And, you know, that's where many of those dating sites will ask you for a reported interest. They will ask you, you know, what are you interested in, right? And obviously, if those things match, you know, they will use that for the recommendations. Like, so for example, in this particular case, you know, if I want to match for some specific reported interest, I can say, okay, look for an interest that is foodie, right? So I will say, okay, for me, I'm interested in foodie. The date that I'm looking for should also have that kind of a reported interest. And of course, in my particular case, have a gender equal to F, right? So that's how you would sort of match for those particular interests. Now, let me just see if I can go there. Right, so here we have, let me just adjust my Rockstar microphone. Right, so here's the demonstrated interest. Right, so I can say, okay, Jonathan, no, that's not another one, that's another one. Yeah, that's this one. Right, so the query here is, you know, I'm matching for Jonathan. He has an interest called interest, right? And I'm doing a second match, right? The second part of the pattern, which basically says, well, there should be another person that shares that same interest, right? So this thing and that thing are identical, right? If I find those people, then I'm obviously going to have another way of recommending potential dates for these people. I'm basically doing another kind of a join operation and finding other potential candidates, right? Matching for specific interests. Now, obviously, how do you find interests? Well, we'll get into that a little bit later. The third aspect, you know, you've got the friends of a friends network. you've got the interest graph, then you've got the location graph, obviously, right? And I don't know if you know about this, but lots of graph databases actually are very, very suitable for geospatial information, right? Where you actually include that kind of geospatial calculations into the graph database as well. So for example, here you can have a query that says, okay, I want someone that is within a certain distance of me, right? If I do that, I can actually add another perspective, right? So I've got the interest graph, I've got the social network graph, and I've got the distance, the location graph that are already all starting to play together here. All right, so the safety graph, well, that's the fourth one, which is basically where we'll try to sort of understand, what are people really like? What are they really, are they safe to go on a date with, right? In order to do that, we'll actually try and dig into some people's social network information. Right? People give away a lot of information about their actual behaviors by posting on Twitter, posting on Facebook, not securing it, all of that type of stuff. So which is why, if you look at this particular person, Jonathan Dreamy Man, he has a very bizarre Twitter feed, right? And maybe appropriate for Amsterdam, but it seems like a lot of his tweets are about, his love for some kind of chemicals. This particular person, Jonathan Dreamy Man, is clearly into drugs, right? So you can actually derive new kinds of interests from this particular analysis as well, right? If you do some word analysis on these Twitter feeds, it's very easy to sort of infer new kinds of interests and apply that to the graph as well to assess, things like safety. Right, so in this particular case, I can just say, okay, Jonathan Dreamy Man, has he got some kind of demonstrated interest in drugs, right? That would be another perspective on whether or not I should go on a date with this guy, right? So here we go, right? So the queries are getting more complicated, right? The patterns are getting more complicated. We're looking deeper into the network, and we're trying to find a date connected to Jonathan at 2 hops away, and that date should or should not have an interest in drugs, right? So that's the way you would sort of imply these new kinds of patterns and leverage those in your dating recommendations, right? And as you can see, actually, and this is bizarre in some ways, so here what we'll do here is we'll add a demonstrated interest, right? Because Jonathan has an interest in drugs, right? So he has an interest in drugs. We'll add that to the database. That wasn't there before. And now we'll try to look at the friends of a friends who like drugs, for example, right? So here we go, look for a date that is 2 hops away from Jonathan, right? Who is interested in drugs and whose gender is female, right? And then we'll get a number of recommendations. So like I said earlier, right, we're looking at these multiple perspectives and involving more and more parameters, more and more entities into the way we try to recommend new dates to this particular person, right? Other passions, football, for example, food. Is a particular person into food, yes or no? So that type of stuff, you can also sort of include that into the graph. Another one that's very popular with some of these dating users of the graph database technology is, verifying whether or not someone has a real profile, yes or no. There's a lot of fake profiles on these dating sites. And in order to do that, you can actually link out to social networks and verify if these people are real. For example, by assessing if they have a minimum of 1 of 2 posts, for example, right? So if you do that, you have a query similar, a little bit like this one, right? So in this particular case, I'm starting from Jonathan, looking for a potential date 2 hops away, and that date should be on a social network, should have a gender equal to F, and should have a number of relationships, right? So here we're evaluating the number of posts of that particular person on a social network and verifying whether or not this is actually a real person, right? So that's another query that you can run over here. You know, real people with a social network, right? So grabbing Jonathan, walking the nose relationship for 2 hops, walking to the social network and evaluating if R, which is you know, the relationship between the date and the social network, has a number of posts larger than 2. Right? So if you run that, then basically you get only one particular person back, which is Jennifer. Looks like we're zooming into whether or not one particular recommendation for Jonathan. You know, people that are into football, gender F, 2 hops away, into drugs. So this is the perfect date for John, right? So you're drawing this kind of complex pattern for Jonathan to see whether or not that would be something that you would want to recommend. Right? And as you can see over here, pull it all together. This is the query that we're running, and you know, the recommendation is going to be this wonderful lady called Jennifer. So that's really how people deal with these complex patterns in the dating industry. You know, they really look at these different perspectives, look deep into the network, not just 1 or 2 hops, but 3 or 4 hops even, to find people that would be useful to recommend, right? And you know, that's the perfect date. They have a date and they sail off into the sunset. So what's that got to do with business? Right? I'm hoping you sort of got the picture of the graph landscape a little bit. Well, I thought I'd give you a specific example on, you know, how that relates to real-world normal business applications. You know, lots of organizations have to deal with fraudulent behavior, some kind of fraud. You know, whether they're trying to commit financial fraud or insurance fraud or VAT rings. What's that?
Financing drugs.
Yeah, financing drugs, for example. Lots of examples that you could think of in fraud. Now, this is the funny thing about fraud. There's lots of different fraud types, right? And there's this entire industry that digs into all these different kinds of fraud examples, right? And we could go into this for hours, but I think the point I'd like to make is that many of these fraud cases are not just in the individual transaction, right? It's not just one transaction or one behavior or one interaction that actually composes a fraudulent behavior, right? Many different steps are usually involved, and it's a chain of transactions that forms this fraudulent behavior, right? So, for example, in this particular kind of fraud, which is what people call first-party fraud, right? What they try to find is lines of credit, you know, extend credit, and then basically form networks of people that all apply for the same kinds of resources, and then take advantage of the situation and run with the money. Right? This is a very well-known pattern of fraud, right? Where people fabricate these synthetic IDs, you know, have all these smaller lines of credits, and then amass that into something of much more substantial value. People don't read about it a lot because, you know, it's one of those things that the banks try to, you know, shut up about. You know, they don't really want to talk about that because they're the only ones that are hit by this. This is a big problem for lots of people, for lots of financial institutions. So it's a big problem and enormous numbers, and it's a network problem. You know, we usually don't think of it that way. We think about, you know, these individual transactions that people are committing to, individual credit lines, individual assessments, and that's basically what's causing the problem. We don't look at the complex ring of fraud that is actually existing here, right? So, you know, that's why they basically get away with it, right? They have these strategies of, you know, all of a sudden disappearing with all of the credit lines that they've amassed, you know, right? And bust out. That's how they call it, right? They basically run away with the money at the top of at the peak of the credit line and run away with it, right? And the bank, in this particular case, it could just as well be, some kind of other institution, is left with the losses, right? So the discrete data analysis strategy for this, right, where you look at the individual transactions, has been used for decades, right, in order to try to single out these individual fraudulent cases, right? The problem with it is that it's really not stopping the advanced fraudsters, right? It's very simple. It stops the rookies, but it never stops the advanced fraudsters. Advanced fraudsters who are, of course, committing the larger fraud cases, right? There's been this tendency to try and have much more continuous data analysis to try and predict these types of fraud behaviors, and that's where the graph really can come in, because the graph database or the graph analysis is going to allow you to look at these complex patterns, look deeper into the network, just like what the dating sites are doing today, right? They're basically, the dating sites are composing these complex patterns, right? They're looking not just at the friend of a friend network, but also at the passion graph, also at the location graph. They're looking at all of these different aspects, and that's what fraud analysis, for example, should also be doing. They should also look at multiple perspectives to try and find the fraudsters, right? Because we know that non-fraudulent cases in this particular example, they all have the same shape. They all have the same pattern, right? If I look at something like this, I can also immediately start seeing, okay, this really doesn't correspond to the shape that I just showed you. It's a much longer chain, for one thing, right? There's a lot more participants in the chain, right? So I really need to be looking much deeper into the network to be able to evaluate whether or not a particular transaction is of risk, yes or no, right? And that's sort of the point that I'm trying to make, is that you really want to evaluate these types of risk assessments, not just based on the individual transaction or one or two hops deep, but you want to look deep into the network and follow the chain all the way through to be able to make an accurate assessment whether or not a particular card number, for example, is of risk for a particular fraud case, right? Because it's all about these patterns. It's all about these patterns, these deep patterns that are going into the network that are really increasing the risk of the fraud behavior, right? Let me say that again, right? It's just all about the patterns, the deep patterns that you really want to be looking at. Not just one hop deep, but multiple hops deep. For example, here in Holland, we've done this beautiful project with the Chamber of Commerce, right? The KVK, if people are familiar with that. When you register a new organization, new company, you have to go to the Chamber of Commerce, and they will actually check all the way into their network whether or not you or some of your mother companies have ever been convicted, if some of the board members have open debts or those types of things. They will all be checked all the way through into the network, because they know that basically the fraudsters, the people that are wanting to do these types of VAT carousels and all of those types of things, they are basically trying to exploit the system by wrapping companies in companies, in companies, in companies to try and evade the system. It's all about these patterns. It's all about these deep connections between data, right? That's why we're seeing a lot of interest, in connected analysis in fraud prevention, and that's just one application of how business users can learn from these dating sites, because at the end of the day, you're looking at these complex patterns, you're looking at these cross-field type of evaluations of risk. Lots of people are already doing that. There's a lot of information that you can find online, or reference cases, all of those types of things. I've brought some cards here, some books that you can also go and take a look at downstairs at the booth. There's actually a graph of the GOTO Amsterdam schedule that you can also take a look at if you're interested. And of course we have a meetup here in Amsterdam. If you're ever looking for more information or whatever, you can always come to one of our meetups. For example, on the 16th of July, we're doing another meetup here in Amsterdam that is usually really well attended, so it should be fun. So you can always reach out to me, Rik at Neotechnology, Rik Van Bruggen. I have a blog about Neo and stuff as well, so take a look at that as well. And I'm very happy to answer any other questions if that would be useful. Yeah, go for it.
So you talked a lot about looking for the patterns and traversing the network. Yeah. How do you arrive at the patterns you look for? I guess there's, of course, literature, social studies, stuff like that, especially data industry. But can you also use graph databases for exploratory research?
That's a great question. So, for some reason, this thing sounds louder. I don't know if that's for you as well. But so let's talk about that because yeah. You know, the examples that I gave you, you sort of have to know the pattern that you're looking for, right? If you don't know the pattern what you're looking for, then you know it's not going to answer any of your questions. So, I think there's actually multiple ways that you can find patterns. The first one, I think, is you, right? It's your domain expertise, right? You know your business, you know, because you've been working in the industry, what are meaningful patterns that you should be looking for, right? The second one, I think, and I sort of haven't really gone into that here in this demonstration, but I usually actually do other demonstrations. There's a lot of exploration that you can do. If I can just click around here, right, I will find interesting stuff. You know, one thing leads to another, right? And I find that graph visualizations are actually a very meaningful way for people to find patterns that they didn't know about, right? Like for example, I don't know, I tweeted about it yesterday night. Do you know the ICIG? It's the International Center for Investigative Journalism, a mouthful. And the Swiss Leaks case, it was all over the news two months ago. That case, the Swiss Leaks case, where they found all of those hidden files of HSBC in Switzerland, all of that wonderful, interesting stuff, that was found by loading the data into Neo4j, applying a visualization solution to it called Linkurious, right? And then the journalists were just browsing through the HSBC transactions, and they found these really bizarre patterns. Right, so that's the second way you can find patterns. It's, you've got your domain expertise, and then you're exposing it to a domain expert, and he just walks around on the network and finds stuff, right? The third way, obviously, is a little bit more complicated because it involves things like machine learning, right? It involves things like, massive number crunching algorithms that will do things like clustering, right? Graph clustering, it's a well-known technique for finding which parts of the network belong together, right? Or betweenness, which parts of the network actually are most important in the network, or some kind of ranking. Those are all algorithms that you can apply to a graph using machine learning techniques, and they will sort of tell you what the patterns are, right? In my experience, that's the last part, right? Domain expertise and visual exploration, I think, are the most important parts of finding patterns. Machine learning, sure, it can give you that extra percent, right? And oftentimes that extra percent is very interesting, but that's the third way of doing it. Does that answer your question? Yes. Yep. Does anyone else have other questions? I'm not sure if I can run through the... They're recording it, man. It's...
So about the example which you gave, I just want to know on how much amount of data was used for doing this analysis.
I was hoping you wouldn't ask that. No, it's tiny. It's absolutely tiny. I think it's like 100 nodes or something like that. So it's completely tiny. But that's not, actually might be useful for you to sort of understand why that's actually completely irrelevant. The size of the data in a graph database, very different from other database systems, does not affect performance a lot, right? Why? Because in all of those queries that I did there, right, I'm actually making them local. I'm making them local in the graph, which means you're anchoring it to a specific person or a specific user or a specific interest in the graph, right? That's the difference between global and local operations. Now, the wonderful thing about graph databases is that finding the local point where you start your graph search, that's basically an index lookup, right? And if size becomes bigger, yes, that index lookup will go a little bit slower. But once you're in the graph, it doesn't even know about the rest of the graph. It only cares about that locality, about that part of the graph that you've landed on. I always think of it as me wearing a jetpack, landing into the graph, right, and then exploring it from that place where you land. Right. So yes, you've caught me. The data set was very tiny, but it's actually irrelevant. Because I can prove that to you if you want to come to the booth later. If I add 100,000 people to that graph, it doesn't matter. It doesn't affect performance. It just doesn't. Yes. All right.
It's like when we compute these, it's like a pre-computed graph, right? So you actually store it. So how real time is this if I want to just serve it in real time?
Yeah, so no, so this is real time, right? So sure, there will always be some kind of an initial loading process for your graph, right? But at least in the case of Neo4j, it's a fully transactional database. So that means that you will be writing to it all the time, or that's at least what it's designed to do. As you continue to write to it, right, it will always give you the latest pattern matches. Right? So if all of a sudden you add 100,000 people to the graph, right, it will actually, well, in this particular case, it won't really matter, but it will continue to sort of evaluate that locality of the graph. If some new connection is there, it will do different recommendations. Right? So it's a real-time system, or a near real-time system, if that makes sense. Like you would do in other OLTP kind of situations. It catches the latest information and works with that. Does that answer your question? Anyone else? You really want to go to lunch, don't you? Yeah.
And how this system deals with the big updates? If you have a really big bunch of data in the end, then you need to update a lot of things.
Another great question. So depends is the good answer, but I don't want to sound like a consultant too much. So writing to a graph is always more expensive, right? So more expensive compared to like a key value store or other kinds of NoSQL systems. Writing to a graph is more expensive because you're writing data and structure at the same time, right? You have to do both, right? So it's going to be more expensive. So expect a little bit of an overhead, right? Luckily, most people read their data more than they write it, right? So it usually balances out. In the case of bulk operations, where you need to load a bunch of data all at once, you basically have two options, right? Do it online or offline. If you do it offline, it's going to be really fast. I was talking to a guy earlier today that wanted to load 300 million nodes and that type of stuff. Online, it would take days. Offline, it's going to be minutes. It's going to be a lot faster. Very, very big difference. If you're doing online bulk uploads, you really need to be a little bit careful because there's a lot of things that you can tweak. The most important thing to tweak is the transaction sizes. Right? If you do atomic transactions all the time, right, come back in a couple of days because that's a big overhead. Right? If you can say, you know what, I can afford to commit every 5,000 updates, right? Guess what? It's going to be a lot faster, right? So, but it depends on that, you know, balance that you need to strike. And you know, it's too big of a topic to sort of address here, but I hope you understand the topic, right? So offline and online, very different. If you're doing online, please take care of your transaction batches, the batch sizes. Anyone else? Yeah. So Bram has been kindly reminding of me that you need to evaluate the session. So if you're kind enough to do that, there's an app for that, right? So you can do that on the GOTO app. I also have a couple more details here. We have some books left. I actually, you know, because I don't have a social life, I wrote a book about Neo. And you know, there's a couple more copies downstairs. So if you're interested, you can come and get that. There's also downloads from PDF books. You know, the O'Reilly book is a free download. The Learning Neo4j book as well. And at 1 o'clock, there's a raffle for one of those Android watches. So if you're interested, please let us know. I hope this was useful. I know I flew through it a little bit, but I'm hoping it was useful, and I look forward to seeing you again.